Good morning, everyone. Today, let's talk about random number generation, or more specifically, linear random number generation. So, when we start, we're going to first talk about what is random number generation and what is the math behind the random number generation and some applications of random number generation. Let's begin with the introduction. So, random number generation is a process of sequentially generating integers that passes some statistical test. That means like all the integers should be drawn from a uniform distribution, and all the random numbers looks random, but they are not purely random. We'll see a reason why when we go to the math behind it. So how it generates a random number? A random number is generated by a mod function, at least the linear random number generation. The functions look like ax plus c mod m. Mod m is to make sure your random numbers are within your range. For example, if I have to generate random number from 1 to 100, I'll put mod m is equal to 100 or 101. So it will generate from 1 to 100. And to generate random numbers, we have to first choose initial seed. That will ensure that every time you generate a random number, same random number will be replicated for your experiment or your research or your analysis. So let's do an example of random number generation. The function looks like x plus c mod m. So we choose a is 79, c is 71, and m is 100. Seed is 263 to make sure it's replicated. So choice of seed always get the same result. So if we do, so that there was a calculation there, maybe some kind of typo with the PowerPoint. But if you take 79 is a, so 79 times c, 263 x is c, plus 71 mod 100. You do, and you get a result here. And you do the same thing. You repeat the process, and you get the other random number. So every time you keep getting next random number. But this, because of the mod n, this may get a cyclical division. It's a cyclical division, so it may get repeated. That's why it's called pseudo-random numbers, not pure random numbers. So you can do all the calculations, or we can use the code to generate random numbers for us. In R, you do sample 1 to 100. You need one random integer, so you 1. And in Python, you have to import the random class and then do the same thing. So applications of random numbers. Random numbers are used everywhere. In machine learning, in simulations, in cryptography. In machine learning, we use random numbers for bootstrapping, Monte Carlo, subsampling, or getting your test set. And then in simulations, people use random numbers to make a better simulation of movement of gases or colliding of galaxies, or in physics, in biology, in chemistry, everywhere. And random numbers are also used in cryptography. For example, our star ID, for example, it's kind of randomly generated. Or we can have our password randomly generated. Our database has some keys that are randomly generated. Hash tables use hash functions to generate random numbers of the table to give us a key. So it's used everywhere. There are endless opportunities of uses of random numbers. So random number generation is an ongoing research topic because we want to make it more random, but we don't know what random is. And so people have used all sorts of methods to generate random numbers. Some people have used radioactive decay, for example, as strontium or some radioactive isotope. The decay of those isotopes are random, we can't predict those. So they use that decay to generate the pure random number. Or some people use movement of gas on the box when you increase the temperature. All sorts of physical activities or physics is used to generate random numbers. And good random numbers improves a lot of algorithms. For example, Monte Carlo, the algorithm we know, is better when there is pure randomness on it. So let's recap and conclude what we talked today. We talked about what is random number generation and what is the math behind it. We did an example, and we also saw a code in R and Python to generate integers for us. And we also knew about where is random number applied. All the applications of random numbers. Thank you.